We have a rational function and we're asked to find several things: domain, intercepts, asymptotes, where the graph intersects its horizontal asymptote if it does at all, and then tie that all together to sketch. Okay, so our first one is 2x plus 4 over 3x minus 5. Now my recommendation is always first see if you can factor and cancel. Now out of this numerator I can factor 2, but out of the denominator I can't factor anything, and nothing cancels. Okay, so now I'll just take these somewhat in order. I might skip around a little bit. Domain. Domain comes from taking the original denominator, setting it not equal to 0. So that, of course, is 3x cannot be 5, or x is not 5/3. Now I'm going to go ahead and skip to asymptotes because vertical asymptote is very similar to domain. You take the reduced denominator, which in this case is the same as the original because nothing canceled, but this time set it equal to 0. And since the algebra is going to be exactly the same, I can just cut right to the answer. The vertical asymptote is at x equal 5/3. Now what about horizontal asymptote? Okay, horizontal asymptote comes from comparing the degrees. The degree of the numerator to the degree of the denominator. In the numerator, highest power of x is an x to the first, so that degree is 1. In the denominator, it's also an x to the first, so that degree is 1. When the degrees are the same, the horizontal asymptote is y equals the ratio of the leading coefficients, the numbers in front of x to the first. So that will be y equal 2/3. Okay, now intercepts. Y-intercept is usually the one that's easier to find. Here we put in x equals 0. Now remember the function notation, g of x, is the same as y. So it's 2 times 0 plus 4 divided by 3 times 0 minus 5. That's going to be 4 over negative 5, which is negative 4/5. Okay, x-intercept is going to involve a little bit more algebra. The general idea for any x-intercept is to set y equal to 0. So again, that means the function is going to now equal 0. And what we have is a rational equation. The first step in solving a rational equation is to eliminate the denominator. So I'm going to multiply both sides by the denominator of 3x minus 5. Now watch the simple things here. This side you've set equal to 0. 0 times anything is 0. Here the denominator cancels, and we're left with just the numerator, 2x plus 4. Now that's just a linear equation to solve, so we'll subtract off the 4, divide by 2 to get an x-intercept at negative 2. If you're good at remembering shortcuts, and I hope you reason through the reason why we can do this shortcut, notice that when I set the entire thing equal to 0, first step is multiply by the denominator, and that always comes down to just solving where the numerator equals 0. And if you can remember that shortcut for the x-intercept, that's fine. What I will caution you with is do not confuse that with finding domain or vertical asymptotes. Domain and vertical asymptotes come from the denominator. The x-intercept comes from the numerator. All right, now we have one thing else left to find, whether or not this graph hits its horizontal asymptote. So that's just something that can give us a little bit more of a perspective on the graph of this function. So hits horizontal asymptote. I'm going to put a question mark there. We found the horizontal asymptote to be 2/3. So I want to know, does 2/3 equal the original function? Okay, so that's the question that we have to ask. And then in order to solve that, again, notice that we have a rational equation. So we're going to multiply both sides of the equation by the denominator 3x minus 5. Okay, and this side the 3x minus 5 cancels. Here I get 3x minus 5 times still a 2/3 equal my numerator 2x plus 4. And then now I probably should have done this to begin with, but I also have a denominator on this side. Let's go ahead and multiply by that denominator as well to get rid of all the denominators. So on this side I have 2 times the quantity 3x minus 5. And on this side, again, I have 3 times 2x plus 4. Now if I distribute, I get 6x minus 10 equals 6x plus 12. The 6x's cancel, and I'm left with negative 10 equals 12. Now when I look at that, that says that the number negative 10 has to equal the number 12 in order for this to be true. And of course we know that is not true. So this tells me that this does not intersect the horizontal asymptote. No value, we'll say. Okay, now we're ready to put all this together on our calculator and graph. And of course, a step would be to put it on the calculator to compare, but I seem to have misplaced my calculator. So I don't have one right now to show you, but we can put this together with the info that we have. Okay, so vertical asymptote is at 5/3. Vertical asymptotes should be dashed lines. Horizontal asymptote is at 2/3. Again, that should be a dashed line. We have a y-intercept at negative 4/5. Now I'm going to label that point, but I'm going to hold off and label it here in just a minute after I see the rest of the graph. X-intercept is at negative 2. And again, I'm going to label this, but I'm going to wait and see what I have. Okay, and now we want to look at this on the calculator. But again, I don't have a calculator with me. So you need to make sure to put this in your calculator correctly with your order of operations. So it should be y1 equal parentheses numerator divided by parentheses denominator. Make sure you have your parentheses. It is your job to tell the calculator how you want this graphed. And if you don't have the parentheses in, it will not graph it correctly. Okay, now, asymptotes guide the graph. From these 2 points, I know that on this side of the vertical asymptote, if I follow this vertical asymptote and this horizontal asymptote going through these 2 points, my graph is going to have to look something like this. It should be curved. It should never hit the vertical asymptote. Sometimes graphs can hit the horizontal asymptote, but we have found that that does not happen on this one. So I know that this portion of the graph has to look like this. Now what about the right side of the vertical asymptote? Just from the asymptotes, I know it's either going to be up here or down here. And from the other information that I have found, my only x-intercept was at negative 2. If the portion of the graph is down here, it would have to have another x-intercept, and it does not. So I know it must be up in this region. And again, it's got to follow my asymptotes. Graphs never hit a vertical asymptote, and we have found on this one that it will not hit a horizontal asymptote. Now, of course, you can confirm that on a calculator, and I highly recommend that you do. Don't trust the calculator graph exactly. Sometimes calculator graphs like to put a straight line in here for the vertical asymptote. You need to recognize it's dashed. You should have arrows at the end of each of these points. Your graph should not look like an L shape. It should be curved. Your graph should pass the vertical line test. So in other words, don't loop it around. It needs to satisfy the vertical line test where every vertical line would hit the graph once and only once. But there we have used all of our information to get a very good sketch for this graph.